flux core and MIG stainless steel and the techniques and the setup. For the machine setup, you'll obviously be on DCEP for MIG or flux core. For flux core, this current provides better base metal penetration. We are going to be demonstrating MIG today because there really isn't much difference with the flux core, like overall with the process and everything. You'll change your wire type. We're using 308 stainless, so we will be putting that into the machine. Our diameter is 035.
Just put your phone down.
There we go.
Okay.
I just changed the wire over from the carbon steel to the stainless. Changed the dry roll. You would want to set the inductance to a higher level to improve the puddle fluidity and the wetting, because the surface tension of the stainless steel weld puddle doesn't allow the molten metal to flow to the edges of the weld. You would ideally use a Teflon wire liner because it ensures good wire feed and would help prevent contamination. It makes sense to buy a larger torch for stainless steel MIG because of the higher heat produced. These are all the shielding gases that are most common. The 7525 is most common for the flux core, and the trimixes are the most common for MIG. To select the shielding gas, you need to first determine what materials are going to be joined together, what filler you're using, and what process you're going to be using. Then you need to look at the available gases that you have to determine the best fit for the application and the requirements of your product. According to my research online, it runs better as just stringers, just strictly stringers. For the techniques of MIG stainless steel, you really want to run the stringers basically how you would run just regular steel. The technique will vary person to person and depends really on the application that you're doing. You can either do slight stepping motions, E-oscillations, zigzags. It's really whatever you're comfortable with. You also need to manage the heat and distortion. It's a very easy metal to warp and distort, and you should limit the weld size to the smallest possible that is necessary for the strength of the application. Using lower volumes of weld metal reduces the resulting shrinkage stresses and warpage to the material. And you can even use nickel-plated copper backing bars. For MIG, you want to use a push angle, and for flux core, you want to use a drag angle when you're running it. Flux core, dual shielded or self-shielded, will require a longer stick out as opposed to MIG for stainless. It's typically around 5/8 to 3/4 inch. Make sure your machine is dialed in correctly, number one. And if you're still having spatter issues, you can use anti-spatter spray or spatter reducing nozzle to manage. For a dual shield flux core, it has very little to no spatter, so you shouldn't have any issues. As you can see by my ugly little science project, you need the right shielding gas. You need the right shielding gas. If you're brand new, you don't know what gas you need, look it up. There's so many charts online. I had the pleasure of going to Phoenix Metal Products today. They let me come in and film some videos, and they were very helpful and answered every single question that I had. And I got to see what applications that stainless steel MIG may be used for, and they showed me different techniques that each of them all use. They use a trimix blend of gas with helium, which seems to be pretty common.
Yeah! Okay, love you guys. Don't forget to smile.